The first step in the machine learning workflow is to define the machine learning problem you are trying to solve. You might be wondering, how we even start to define a machine learning task? First, we define a very specific task. Think back to our snow cone example. Now imagine that you own a frozen treat store and you sell snow cones along with many other products. You wonder, how do I increase sales? This is not a specific task. It is too broad. A machine learning practitioner might frame the problem differently, such as, does adding $1 upcharge for sprinkles on a hot fudge sundae increase the number of snow cones sold? Or another example, does adding a 50-cent upcharge for mixing flavors increase the number of snow cones sold? Next, we want to identify the machine learning task we should use to solve this problem. This will help us better understand the data we need for the proposed project. We will look at some examples in more detail. What exactly are machine learning tasks? All model training algorithms and the models themselves take data as their input. The outputs, however, can be very different. They can be classified into different groups based on the machine learning task. The characteristics of the input data actually help define which machine learning task can be used. Two common machine learning tasks are supervised and unsupervised learning. We have reinforcement learning as well, as we briefly talked about it before, but you will learn about reinforcement learning in a later lesson. One way to break down these machine learning tasks is based on the type of data you need to train your model. Most data can be described as either labeled or unlabeled data. So what is the difference? Let's talk about supervised learning first. We use the term labeled data to refer to data that already contains the solution, called labels. Let's think back to our snow cone example. What were we trying to predict? We were trying to predict the number of snow cones we would sell. Those data points are solutions, or labels. We use both the number of snow cones sold and the temperature to generate the best fit line on the graph. Another type of machine learning task is unsupervised learning. As you might guess, we call data unlabeled when we don't have the solutions or labels. Let's look at a couple of examples here. Take a quick look at this picture. What do you see? Your first thought might be a tree. You just labeled this picture, but a computer initially only sees that image as a matrix of pixels which represents that image, not the whole image. Here's another example. Imagine that you work for a company that recommends books to readers. To provide better recommendations to your readers, you want to discover unknown microgenres. You are fairly confident that these genres exist. It would be impossible for you to read every book in the world to ensure that a particular microgenre exists. But words and phrases used in the book description might provide some guidance on which microgenre a book belongs to. Because you don't know which microgenre exists, you cannot use supervised learning technique here. You don't have labels. Instead, you can use a common unsupervised learning technique called clustering to determine if books have some natural grouping. We will take another look at this example of unsupervised learning in a real-world scenario later in this lesson. Just as we initially divide a task based on whether we had labeled data or not, we can continue to further define the machine learning task based on the type of label. Imagine that we trained a machine learning model to predict the type of a flower based on images. In this example, our label is categorical. We are performing a classification task. In our snow cone example, we were trying to predict the number of snow cones sold on a given day based on a temperature. Our label is a number that could in theory be anything. In that case, we are performing a regression task. These are just two of the most common examples. You will find many other types of supervised learning tasks as you explore the machine learning space. Similarly, with unsupervised learning, you can further narrow the scope of the machine learning task you're working on. In our book macro genre example, clustering is one common application of unsupervised learning. As you explore the machine learning space, you will find many other types of unsupervised learning tasks, such as neural networks.